Write an equation for the hyperbola with foci 1, -5 and 1, 1 and transverse axis length of 4 units. Let's sketch these points. We have 1, 1, 2, 3, 4, 5. We have 1, -5 and 1, 1. Now the center of this hyperbola will be halfway between the focal points. We have 1, 2, 3, 4, 5, 6 units separating them. So we need to go down 1, 2, 3 units. There's the center. 1, -2. Center is 1, -2. We can already start to write this. Now if this is the focus, these are the foci, then this hyperbola is opening up and down. This is y plus 2 squared over something minus x minus 1 squared over something is equal to 1. And it says the transverse axis of length 4 units. That means from the center, the transverse axis, we go up 2 right there and down 2. So that means the distance from the center to the vertices are that's going to be 2. Now that's going up and down, so that puts 4 under here, 2 squared. And then we know that C is 1, 2, 3 units. So C is 3. We know A is 2 units. We have 9 is equal to, we have A squared plus B squared. So B squared is equal to 5. So 5 goes under the X. Write an equation for the hyperbola with vertices at 3, -3, 10 and -3, -2 and conjugate axis length of 6 units. Let's plot these points that were given. We have -3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So -3, 10, and then -3, -2 right here. That means 12 units separates the vertices. So the center is 6 units up. 1, 2, 3, 4, 5, 6. Now that puts the center at -3, 1, 2, 3, 4. -3, 4. Now these are the vertices. Again, we have this vertical hyperbola. That means y is going to be first. Y minus 4 squared over something minus x plus 3 squared over something is equal to 1. Now the distance from the center to a vertice is 6 units. That means 36 is going to be under the y. Now it also says the conjugate axis is a length of 6. So from here to these little helping points is 3 units. So the distance from the center to these kind of helping points is 3. That's the B. So B is equal to 3, and now I know that I need to put 9 under X. Write an equation for the hyperbola with focus or foci at 13, -3, -5, -3, and conjugate axis length of 12 units. Let's plot the points that were given. 13, let's say that's 13, and then -3, 13, -3, and then -5, -3 would be, let's say, here. So that's 18 units across. So I'd go 5 and then another 4. That'd be 9 units. And that right there is the center. So the center is 4, -3. 4, -3. Now they gave us focal points, but the vertices are somewhere right here. That means that this hyperbola is opening up left and right, which is a horizontal. That means X is going to be first. We have X minus 4 squared over something minus Y plus 3 squared over something is equal to 1. And we know that C is from here to here. That's 9 units. So C is 9 because that's from the center to a focal point. Center to a focal point. And the conjugate axis is the length of 12. So that means we're going 6 up and 6 down. But that's B. So 36 is now under Y because we're going 6 up and 6 down. But we now know that B is equal to 6. And C squared is equal to A squared plus B squared. So 81 is equal to A squared plus 36. So A squared is equal to 45. So 45 goes under the X. So here we have the answer right there, letter B. Classify conics using the discriminant. The graph of a second degree equation of the form, equal to 0 is a circle if b squared minus 4ac is less than 0 and b equals 0 and a equals c. So we need to have a circle if a and c equal each other and this doesn't exist. It's 0, the b is 0. An ellipse if the discriminant is less than 0 and either b or a do not exist. So either b does not exist or you could have a not exist and we could have an ellipse. A parabola if the discriminant is equal to 0 and a hyperbola if greater than 0. So if the discriminant is less than 0, we either have a circle or an ellipse. Use the discriminant to identify the conic section in the equation. Well, this is the A. What's in front of y is C. What's in front of x is D. The xy is the B, and the constant is F. So we need b squared minus 4ac. So we have 25 minus 4 times 2 times, I need the c, which is 1. So we have 25 minus 8, which is 17, which is positive, so this must be a hyperbola. Use the discriminant to identify the conic. Well, if we don't have this xy, it makes it a lot easier to identify the conic. Now, if this coefficient and this coefficient are exactly the same, then this must be a circle. In letter C, it says use the discriminant to identify this conic. Well, we have the xy. Now, what's in front of the x is A. This is the C. That's going to be B. This right here is E, and this is F. But what we need is b squared minus 4ac. We have 16 minus 4 times 2 times 2. We have 16 minus 16. That's equal to 0. If the discriminant is equal to 0, then this is a parabola. Use the discriminant to identify the conic section given by this right here. Let's get everybody to the same side. We have 3x squared. We have plus y squared. And really that's all we need to know. But let's get the rest. We have plus 6y. We have plus 14x. And then we have plus 15 is equal to 0. Well, if these two were both 3's, if that was a 3 and that was a 3, it'd be a circle. But because we have a plus and the coefficients are different, this is an ellipse. Without that xy, it's much easier. Let's find out what they are without the xy. Now, of course, if the coefficients are different and there's a plus, that's an ellipse. If we had 3x squared plus 3y squared plus whatever, that would be a circle. If we had x squared and no y squared, and we don't have the xy, that would be a parabola. And likewise, if we had y squared plus 6x plus 2 equals 0, that would also be a parabola because we wouldn't have an x squared. And then if we have x squared minus 6y squared plus whatever without xy, then this would be a hyperbola because of the minus in between.